The second method for solving systems of linear equations using algebra is called the elimination or addition method. In order to be able to do this, you need to be able to identify the least common multiple for a set of numbers. Remember that this is similar to the least common denominator. You need to know how to combine, multiply, and divide integers. Be able to solve basic equations using the multiplication property of equality, and be able to determine if an ordered pair is a solution to a system of equations. Upon completing this presentation, you will be able to solve a system of linear equations using the addition or elimination method. So our procedure in order to solve using the elimination method is, if necessary, rewrite the equations so that like terms are lined up vertically. The best way to do this is to use the general form, or ax plus by equals c. Our second step is to choose a variable to eliminate. Doesn't matter which one we pick, but what we are going to want to do is multiply one or both equations by numbers so that the coefficients are the same but have different signs. In order to do this, this is where we need to know our least common multiple. Our third step is we want to add the straight columns straight down, and one of the variables should eliminate. This is where we get the name of the method. From here, we want to solve the resulting equation for the remaining variable, plug the result back into an original equation, and solve for the remaining variable. And then finally check your solution by plugging in both numbers into each equation. Steps 4 through 6 are the same as what we did when we talked about the substitution method. Alright, so let's look at some examples. Example A is our base case example, only because we don't have to multiply by anything. If you notice here, the y's already would cancel if we added straight down. And so that's what we're going to do. If we go ahead and add straight down, we get x plus x is 2x. My y's cancel, and on the right side we are left with 4 plus 6 is equal to 10. From here, we can go ahead and solve the resulting equation by dividing by 2. When we divide by 2, we are left with x on the left side, and 10 divided by 2 is 5. From here, we want to plug this back into one of our original equations. I'm going to go with the top one since it's a little bit easier to solve for y. We go ahead and plug in x, or 5 for x. We get 5 plus y equals 4. From here, we can subtract 5 from both sides. Our 5's cancel on the left, and we are left with y equals -1. So our solution is 5, -1. So in order to, finally we want to check this. In our first equation, if we plug in, we get 5 plus -1 or -1. And I want to know if that equal to 4. Since 4 is equal to 4, that one checks out. Now remember that we do have to check it in the second equation. So in my second equation, I have x minus y equals 6. We plug in 5 for x minus -1 for y, is this equal to 6? Well, to start off with, we want to go ahead and change -1 to +1. We get 5 plus 1 is in fact equal to 6. And so our solution, 5 -1, does check out in both equations. So that's our base case example. And so far, as you can see, this is probably a little bit easier than the substitution method. And we're going to see that as we continue through the examples. So let's look at example B. Example B, we have 3x minus y equals 11 and 2x plus 5y equals 13. This one, if we add straight down right now, we do not have anything that cancels out. So we are going to have to multiply one or both equations depending on which variable you want to eliminate. So the question is which variable do you want to eliminate? Both of them are going to be relatively easy, but eliminating the y is going to be a little bit easier. What would be the least common multiple for 1 and 5? It should be 5. So what I want to do is I want to rewrite the first equation so that my coefficient of y is a -5, which means that I need to multiply by 5. But remember that whatever you do to one thing, you have to do to the whole equation. So I want to multiply the top equation by 5, giving me 15x minus 5y equals 55. I got this by just distributing the 5 to every single term in the equation. My second equation, since I already have a coefficient of 5, I can go ahead and just bring it down. Or bring it across. And so we still have 2x plus 5y equals 13. From here, we can go ahead and add straight down. We get 15x plus 2x is 17x. We get our 5y's cancel, and we get that this is equal to 68. I can go ahead and finish solving the equation by dividing by 17, and we get x equals 4. So now let's go ahead and plug this back into one of the original equations. I'm going to go ahead and work with the top one. Again, it does not matter which equation you plug this into. So if we plug this back into the top equation, I get 3 times 4 minus y equals 11. We can go ahead and multiply 3 times 4, giving us 12 minus y equals 11. I can subtract 12 from both sides, giving me -y equals -1. And I can divide by -1, giving me y equals 1. So my solution is 4, 1. If we check this, let's go ahead and plug both of these numbers back into both equations. We get 3 times x, which is 4, minus 1. I want to know, is this equal to 11? 3 times 4 is 12 minus 1. We get 11 equals 11, so that checks out. For my second equation, I get 2 times x, which was 4, plus 5 times 1, which was y. I want to know, is this equal to 13? 2 times 4 is 8. 5 times 1 is 5. And 8 plus 5 is equal to 13. And so my solution for 1 does work in both equations, and we're good. So there are the two first examples. Okay, so let's look at some that are just a little bit more challenging. And one of the things that you're going to see is that these are not going to be all that more challenging at all. So let's look at example C. Example C, we have 4x plus 5y equals 3, and 2x minus 3y equals 7. Now, we can do one of two things. We can eliminate the x's, because we would only need to multiply one equation, or we could eliminate the y's because they already have the different signs. I'm going to go ahead and show you both just to show you that it doesn't matter which one you pick. So the first thing I'm going to do is eliminate the x's. If we go ahead and eliminate the x's, what would be my least common multiple? Well, the least common multiple for 4 and 2 is 4. So my second equation, I want to multiply by 2, and that'll get me the 4, but remember that we also need opposite signs so that when we add straight down they cancel. So I want to multiply by negative 2. So my first equation, I'm going to leave it the same. My second equation, if I multiply by negative 2, I get negative 4x plus 6y, we have negative 2 times negative 3, equals negative 14. If I add straight down, my x's cancel. 5y plus 6y is 11y, and 3 and negative 14 combine to negative 11. I can divide by 11, and I get y equals negative 1. Alright, so now if we plug this back into an original equation, I'm going to go with the top one, because either one of them is going to be the same level of difficulty. We get 4x plus 5 times negative 1, since that was y, equals 3. If we multiply, we get 4x minus 5 equals 3. I can add 5 to both sides, and I get 4x equals 8. Divide by 4. You get x equals 2. Okay, so that is solving this using elimination by eliminating x. So now, I'm going to redo the problem just to show you that it doesn't matter which variable you pick to eliminate. Either way, both of these are going to be relatively easy. So what if we decided to go with y instead? So if we go with y instead, I want to know what is the least common multiple for 5 and 3. Think about if you had denominators of 5 and 3, what would be your least common denominator? Well, it should be 15. So my top equation, I want to multiply by 3. In order to get from 5y, or from 5 to 15, I need to multiply by 3. If we do this, we get 12x plus 15y equals 9. Again, multiply everything by 3. In the second equation, in order to get from 3 to 15, I want to multiply by 5. And since we already have different signs, I don't need to worry about multiplying by a negative. So if we go ahead and multiply by 5, we get 10x minus 15y equals 35. From here we can go ahead and add straight down. We get 22x. My y terms cancel, and 9 plus 35 is 44. If we divide by 22, we get x equals 2. Now from here, again, what we would do is plug this back into an original equation. So let's go with the top one again, because for me that one's a little bit easier. We get 4 times 2 plus 5y equals 3. 4 times 2 is 8 plus 5y equals 3. We can subtract 8 from both sides, giving me 5y equals -5, and we can divide by 5, giving us y equals -1. So note that no matter which way you do this, you still get the solution is 2, -1. I'm not going to check this just because, well, we did it both ways, we got the same answer. But you should only pick one of them and run with it, and then check your solution at the end. So let's look at one more example of a basic systems of equations problem using elimination method. We have 3x plus 9y equals 12, and 4x plus 5y equals 2. So the first thing we need to do is pick a variable to eliminate. And on this one, we're going to have to multiply both equations by numbers, and note that we don't have different signs. So one of them we will have to multiply by a negative. So for me personally, I think the x's are a little bit easier to eliminate. We have some smaller numbers going on there, and so that's going to be the one that I pick. So if I wanted to know what the least common multiple for 3 and 4 is, we should get 12. So my top equation, I want to multiply by 4. And my bottom equation, I want to multiply by 3. Now from here, it doesn't matter which one you pick to multiply by the negative. I think that I'm going to go with the bottom one just because we do have smaller numbers down there in terms of our y's, which means that I won't have to worry about negatives when I start doing my solving. So if we go ahead and multiply this way, we get 3x times 4 is 12x. 4 times 9y is 36y. And 4 times 12 is 48. The second equation, if we multiply by -3, we get -3 times 4x is -12x. -3 times 5y is -15y. And 2 times -3 is -6. From here, we can go ahead and add straight down. My x's cancel. 36 minus 15 is 21y, and 48 minus 6 is 42. We can divide by 21, giving us y equals 2. Alright, so let's go ahead and take this and plug it back into an original equation. I'm going to work with the bottom one again because we got some smaller numbers going on there. And so if we plug this in, we get 4x plus 5 times y, we said was 2, equals 2. We can go ahead and multiply 5 times 2, giving us 10. In order to solve for x, I want to subtract 10 from both sides. We get 4x equals negative 8. And if I divide by 4, I get x equals negative 2. So my solution is negative 2, 2. Remember to put your x first. From here you should go ahead and check, but hopefully you kind of got the gist of that. If you plug this in, you should get that this is going to work out just fine. So that is the elimination method. One thing to note, especially on these problems would have been really challenging to solve using substitution method, just because you do have coefficients for every single one of your variables. And so for problems like this, the only method that makes sense and is relatively easy is elimination method. Hopefully you see that with elimination method, we don't go from super easy to, oh my god, how am I supposed to do that? All of these problems are about the same level of difficulty, which is one of the reasons that most people do prefer elimination method over substitution. Alright, so for the final examples, these are going to be special cases. One of the things that we talked about in the first section from this module was, remember we said that you can have one solution, which is what we've been looking at for just about every single problem that we've done. But remember that there were special cases where you could have no solution, where your lines were parallel, or you could have infinite number of solutions, where your lines lie on top of each other. These two examples are going to be one of those last two cases. But what we're going to do is still solve using the same method and see what happens. So if we look at example A, or E, the first thing I want to do is pick a variable to eliminate. I'm going to work with the x's. We have smaller numbers there. And so if we choose to eliminate, we should get that the LCD, or the LCM, is 12. So I want to go ahead and multiply my top equation by 3. I want to multiply my bottom equation by 2, and I do want one of them to be negative. I'm going to pick the bottom one. So if we go ahead and multiply through, we get 3 times 4x is 12x. 3 times 6y is 18y. And 3 times 12 is 36. For my second equation, if I multiply by negative 2, I get negative 2 times 6x is negative 12x. Negative 2 times 9y is minus 18y. And negative 2 times 12 is negative 24. If we add straight down, my x's cancel, my y's cancel, and if I have nothing left over on the left side of the equation, what does it mean that it's equal to? Well, we should get 0. On the right side of the equation, we get 36 minus 24 is 12. And so what do we have here? We have a false statement while solving. This is something we've seen before. We saw this when we were looking at equations of variables or linear equations in one variable, where we had all of our variables canceled out and we still had some numbers left over. So if we get a false statement while solving, remember that this is no solution. Bringing back some of our terminology from the beginning of this module, remember that if there is no solution, it is inconsistent. Remember, consistent talked about whether there was a solution or not. And we also do have that these are independent equations. They are not equal. If you look up here, disregarding the negative, notice that we have one of them is equal to 36, the other one is equal to 24. They are technically different equations. And so in terms of figuring out inconsistent, independent, consistent, dependent, this is another method that you can use. But this is what we end up with for our answers. Okay, so let's look at example F. Example F, we have 2x minus y equals 3, and we have negative 4x plus 2y equals negative 6. So to start off with, let's pick a variable to eliminate. It doesn't matter because everything's going to cancel anyway. Well, let's say we wanted to eliminate the y's. In order to do that, I want to have a least common multiple for 1 and 2, which is 2. And I want to multiply the top equation by 2. This one we do not need to multiply by a negative because we do already have the different signs. And same thing on the x's if you chose that one. So if we go ahead and do this, we get 4x minus 2y equals 6. The bottom equation, remember we said that we're going to leave that one the same because it already has the 2 for the y. And so we have negative 4x plus 2y equals negative 6. And now when we add straight down, we get our x's cancel, our y's cancel, leaving us with 0. And on the right side, we get our 6's cancel, leaving us also with 0. So what does this mean? Well, we have a true statement while solving, which means that this has an infinite number of solutions. These are essentially the same equation. If you look back at when we multiplied, notice that these are exact opposites. One of them, the bottom one, is just negative 1 times the top one. And so since they are the same equation, we do have infinite number of solutions. Remember that since we do have solutions, this is going to be a consistent system because we do have at least one solution. And since our equations are basically the same, it is a dependent, they are dependent equations. So this is the other way that you can check and come up with solutions, or do the problem involving consistent, inconsistent, dependent, independent. So those are our two special cases, and hopefully that makes a little bit more sense in terms of other ways that you can find this. All right, so when will you see this again? Depending on how far you proceed in your mathematical journey, you may talk about larger systems of equations and possibly matrices. When looking at these types of problems, the basic computations you will be performing will be the same ones that we used in this section. So now take a few minutes and try solving the following equations on your own and see what you come up with. Bring your answers to class, as well as any questions that you have over the material in this section. Please take a moment to pause the presentation before moving on to the last slide so that you can go ahead and work on these. Once you are done, continue the presentation. As a final note on this section, please take a moment to answer the following questions. How confident are you with the material presented? What from this section needs to be explained further? And how much more practice do you need to be comfortable with the topic?